Hi, in this video, in the classes and objects series, I'm going to be talking about a very special method called compareTo, which is very useful to compare objects. You cannot compare two objects with the equals primitive operator. In this example, let's say R is a rectangle of size 2 by 3 and S is a rectangle of size 2 by 3 as well. When I run the code, you can see that they are both of size 2 by 3 with area equals 6.0. If I write if R equals S, display same, else display different. Contrary to what you might expect, it will display different, as you can see over here. The reason being, R is a reference to some memory where the instance variables are stored. Similarly, S is a reference to a part of memory where its instance variables are stored. What R equals S is checking is if they both point to the same memory, which clearly they don't. What you can do is you can copy one object into another object. So if you say rectangle S equals R, instead of S being a completely new object, S is a shallow copy of R. So we say that R and S both refer to the same part of the memory. Now when I run this, it will say same. If you want, you can display the values of S as well. So S width, S height, S area. Let's run this. So you can see that they are the same. A quick confirmation of this fact that they are actually the same is if I put a breakpoint on line 15 after S is constructed and I enter the debug perspective, you can see that R and S have the same ID, which means they refer to the same physical location in the memory. But if I say rectangle S is a new rectangle of size 2 by 3, you can see it's the same values for instance variables. Enter the debug perspective. Now this time you can see that R has an ID of 20 while S has an ID of 23. So they are different physical instances of the same class. They just happen to have the same values for the instance variables. So when such is the case, when there are two objects that you need to compare for equality or for which one is more, which one is less, we use a method called compareTo. compareTo traditionally returns an integer. As we know, all these are instance methods, compareTo and area and is square. They are all called on some object. So when you say s.area, you're calling the method area on object S. Similarly, the method compareTo is also called on some object. So the way you're going to call it is if R dot compareTo S equals 0. Here we get a compilation error because I still don't have a return statement in my compareTo, so let's just put that. Here R is your calling object and S is the parameter that is passed to the method. When I go to the method, you can see that the formal name for that parameter is other. So you're saying that other is whatever the value object is passed is, which is S. So other becomes S. So again, this is a shallow copy. So in terms of the function invocation, other refers to this object. Now what about the calling object? Now whatever object you call a method on is copied into a special object called this. In this case, I'm calling the method on object R, so this becomes a shallow copy of object R. This is also explained in the lecture notes that I have, classes and objects. Comparing objects, right at the very end you can see that I have this method public int compareTo rectangle other. The call is r1 dot compareTo r2, where r1 and r2 are the two rectangles. In this case the calling object is r1 copied into this. The parameter object is r2 copied into other, and that's the diagram. This is a shallow copy of R1, other is a shallow copy of R2. So the compareTo method, now what it returns is pretty standard. It returns 1 if calling object this is more than parameter object other. Similarly, it returns -1 if the parameter object, if the calling object is less, and it returns 0 is if this equal to. Now how do you define more than, less than, equal to? So the criteria has to be defined. So the criteria is area. Now deliberately I'm going to write some buggy code. So what I'm going to do is I'm going to check if this dot area, which computes the area of the calling object, is more than other dot area, we return 1. Similarly, if this dot area is less than other dot area, I return -1. And buggy, if this dot area equals other dot area, I return 0. If that's your code, you'll see that all three return statements, return 1, return -1, return 0, are conditional. Yes, mathematically I know that one of them and only one of them will be true, but in terms of programming, the language doesn't. So if I create a control flow diagram for this piece of code, you can see that it is possible some code at the very end. It is possible that it follows the false, and the false path and reach here. So I don't want that option to be there. Now you can see that if this is more than, this area is more than a dot area, it will return 1, which means if it comes to this line, means this area is not more than other area. Now once you check less than, if it comes to this point, it means this area is not more than and not less than other area, which means there's only one option, so you don't have to check it, and you can return 0 unconditionally. So now when I take a look at this thing and have the last return 0 unconditional, as I explained, and let's have some code here. At the end I'll show you some code. You can see that it can never reach the sum code without returning 0. So all my leaves of the graph return a value 1, -1, or 0. So let's go back, and now you have this thing. So we'll run this, and you can see that it actually does display same because R and S do have the same area. Similarly, an object of size 3 by 2, 2 by 3 will be the same. Also, object of 2 by 3 compared with 6 by 1 will be the same because they have the same area. What about 2 by 3 compared with 2 by 6? You can see that R is of size 2 by 3, S is of size 2 by 6, and because calling object is smaller than parameter object in terms of area, it returns -1. So instead of this condition, let's just display the outcome of compareTo, and you should get -1 here. Similarly, if it's 2 by 3, you should get 0, and if it's 2 by 1, then R is bigger, of size 2 by 3, so you should get +1. So ordering two objects helps us sort them when the need arises. One last thing I'm going to do is I'm going to put a breakpoint inside the compareTo method and store this in a variable outcome, where outcome is r.compareToS. I'm also going to put a breakpoint on line number 20. When I enter the debug perspective, please note that the method call was r.compareToS. You can see, let's go back a little bit, have a breakpoint here as well, and debug again. So we're on line number 19 right now. Int outcome equals r.compareToS. Stop and debug, sorry about that. Line number 19, r.compareToS. R has an ID of 21, S has an ID of 23. Remember these IDs. R is 21, S is 23. When I resume execution, it goes into the compareTo method and take a look at the IDs of this and other. This has an ID of 21, other has an ID of 23. These are the same IDs as R and S respectively, proving that this is a shallow copy of R, other is a shallow copy of S. And that's about compareTo. Thank you for watching and hope you benefited from this video.